Okay, our last example for solving log equations. In this case, we have logs, a bunch of logs. They're all base e this time. This is all natural logarithms. We've got two logs added together on the left, and this equals a single logarithm on the right. Now, in the last video, I explained how if you have one logarithm on each side of the equation, then you can cancel those logarithms out, or just set the inputs equal to each other using the fact that it is 1-to-1. But in this case, if you have multiple logarithms added together on the same side of the equation, you can't just cross them out. Doesn't work like that. So don't just cross out all your logarithms right away. That is not a valid thing to do. So what you got to do instead is combine them into a single logarithm using log properties, and then you can cancel them out. So step one, use the log property. In this case, we're going to use the product rule that says, in this case, adding two logarithms together is the same as a single logarithm with the inputs multiplied. So there's x plus 1 times x inside a single logarithm. That equals the natural log of 6. So now we can use the fact that the natural log function is 1-to-1. So if its outputs are equal, which is what this is saying, then its inputs must be equal as well. So we can do it. We can cancel the logarithms as long as the bases are the same because of the fact that it's 1-to-1. Okay, in other words, you can do like e to the power left side equals e to the power right side, and then the e's and the logs will cancel each other, leaving us with this. So now let's see what we have. Now, distributing the multiplication by x, here we have x squared plus x equals 6. So x squared plus x minus 6 equals 0. We're down to a quadratic, folks. Great. We can solve quadratics. This is a factorable quadratic. We have x plus 3 and x minus 2. Right? Multiplies up to -6 and adds up to 1. So then from here we have x is -3, and from here we have x is 2. But hang on a second, folks. We're not just done. Okay, we have two x values, but are these valid x values? Are these valid inputs to the original equation? You have to go back all the way to the original and ask yourself, is it okay to put these numbers in? Let's check these. If x is -3, we would have the natural log of -3 plus 1 plus the natural log of -3 equals the natural log of 6. Okay, it might be the case that -2 times -3 equals +6, but each of these logs individually is not valid. Not valid. Because on the left we have -2 inside the log, and on the right we have -3 inside the log. So both of those are logarithms of negative numbers, which we are not dealing with. So that means this x equals -3 is not valid. Let's check 2. Is 2 valid? Natural log of 2 plus 1 plus natural log of 2 equals natural log of 6. Okay, now they're valid because that's a +3 and this is a +2. That's fine. Natural log of 3 plus natural log of 2 equals natural log of 6, and that should be just fine because we can use that product rule to get 6 equals 6. Yeah, they're both natural log of 6. So that one is okay. So it doesn't mean that negative numbers are always bad and positive numbers are always good, but what you've got to do is you've got to take the numbers and put them back into the original equation and make sure that whatever is inside of your logarithms, okay, the variable expressions that are inside your logarithms, 6 is obviously fine, there's nothing you need to worry about there. But the variable expressions inside your logarithms, you got to make sure those are positive. Otherwise, it's not a valid solution. So there you go.